So we're talking about linear functions, and to identify a linear function, it's a function whose graph is a non-vertical line. A linear function has a constant rate of change, that would be your slope, and can be represented by a linear equation with two variables. That means an x and a y, right? A nonlinear, that means not linear, does not have a constant rate of change, so its graph is not a line. So a line is like this, right? This would not be linear because it's not a line, right? That's a curve. So a constant rate of change, that means like I would go maybe up 2 over 2, up 2 over 2, up 2 over 2. The rate of change is the same on the entire line, okay? Otherwise known as my slope. So if I'm looking at something, I should be able to look and decide if it's a line or not, right? So if you look at number 1, I have a curve. Is this a line? No. So this would be non-linear. But you look at number 2, is number 2 a line? Yes. So we would say yes, that is linear. All right, what if I'm given a table? Okay, this is where you're going to build something in your mind, and then when you get to Algebra 2, we're going to expand that a little bit more. So the first thing you want to do is make sure that your x values are going up the same. So in other words, 3 to 6, that would be adding 3. 6 to 9, adding 3. 9 to 12, adding 3. So that is correct, right? Then you're going to look at your y's and do the same thing. So to get from 36 to 30, I would have to subtract 6. To get from 30 to 24, I would have to subtract 6. And to get from 24 to 18, I would have to subtract 6. This is called your first differences. When your first differences are the same, then that means that this is linear. All right? I apologize to those of you who are watching this. The bells are off. All right, so I've got a linear function. When my first differences are the same, it is linear. They have to be the same the first time I do it. If they're not the same and then I have to do it again, then that's when you get into things like quadratics and cubics and stuff like that. So if you look up here at your x's on number 4, make sure that they're going up the same. So I'm going up 2, up 2, up 2, correct? So then I look at my y's. To get from 2 to 9, I would have to add 7. To get from 9 to 20, I have to add 11. And you can just stop right there. Are those first differences the same? No, so this would be nonlinear. I will tell you this, you need to check every single one because they could throw you for a loop, right? And then at the end do something different. I don't have to on this though because I've already shown it's not the same. Okay? All right. Now let's talk about these equations. When I say degrees, I'm talking about powers, all right? So if you have an x to the first power, and that's the biggest one that you have, that would equal a linear function. If you have a biggest power of x to the second, x to the third, x to the fourth, so on and so forth, that means that is non-linear. So if I'm looking at this, I don't care about the y. Don't look at the y, okay? But look at this. I have x to the first power. Do you see an x raised to anything bigger than a 1? No? So this is linear. I should also point out that like if I had like a square root symbol or anything like that, that's not linear. Okay? It has to be just a y with an x to the first. All right? So if you look right here, your biggest power would be x to the first. So that means that this is also linear. All right? So if you look at this, this has an x to the second, so that means that this is non-linear. I can't have anything bigger than or other than x to the first, right? All right, see how I have this x that has a square root over it? We definitely know this is going to be non-linear, but I'm going to tell you why. To be linear, you have to have an x to the first, right? No other x's, just an x to the first. If I write the square root of x, I can write that with a power. Because you guys already know that I can rewrite a square root with a power when I take this number right here and divide it by the root number, right? We did that when we were simplifying square roots. So this is actually x to the 1 divided by 2. And is that a power of 1? No, it is not. All right, so that's why that makes a nonlinear. So to be linear, you have to have one x that has a power to the first power. You can't have a second power, a third power, a 1/2 power, a 1/3 power. No roots in there, okay? And that's pretty much it. All right, so let's talk about discrete and continuous domains. So a discrete domain is a set of input values that consists of only certain numbers on an interval. So like if I said the integers from 1 to 5, integers are no decimals, right? So 1, 2, 3, 4, 5. That's a discrete domain, right? A continuous domain is like all of the numbers from 1 to 5. So see how that is a continuous, it's all the way between, it's not skip hopping and jumping around, okay? So continuous is when you connect one dot to another, or let's say I had like that one graph that was on your homework that went like this. I'm going from here all the way to here, right? That would be continuous. But if I did this, and I didn't connect the dots with a line, okay, or a series of lines, then that would be discrete, right? I would be hopping from here to here to here to here. So do we see the difference between a discrete domain and a continuous domain? All right, it's probably easier if you identify, okay, this is continuous, oh, this is not continuous, so it's the other one. Continuous is probably the easiest one to think about.